Hello everyone, and welcome to the online lecture for college algebra. In this video, we're going to cover section 1.4 on linear equations, which are equations of lines. So to begin with, we're going to talk about one of the core concepts when it comes to lines, and that is the slope of the line. And what the slope is supposed to be is a measure of how steep the line is, how fast it is increasing from left to right, or how fast it is decreasing from left to right. So the way we find slope is we define it as between any 2 points on the line, it is the ratio of the rise of the line, how much the y values change, over the run of the line, how much the x values change. So again, rise is change in y, run is change in x. Now in math, we often represent change in with the lowercase Greek letter delta. So oftentimes slope will be described as delta y over delta x. Borrowing from the same concepts that we used for the distance formula in the previous section, if you have two ordered pairs, x1, y1, and x2, y2, then the change in y, the rise of the line, you can find by just subtracting the y values, y2 minus y1, and the run of the line, the change in the x values, you just subtract those as well, x2 minus x1. Now if you're just given two ordered pairs, it doesn't matter which one you label as x1, y1, which one you label as x2, y2, the only thing that matters is that you're consistent. Once you decide, the x and the y value of one ordered pair always comes first, and the x and the y value of the other ordered pair always comes second. You don't want to mix and match. Otherwise, the sign of your slope will be off. So in example 1, we're just going to work some slope problems. We're given two pairs of ordered points, and we're asked to find the slope of a line that would pass through these two ordered points. So for both, it's just rise over run, change in y over change in x. So take a minute, pause the video here, and see if you can find the slope of these two lines. All right, so for part A, change in y over change in x. For the y values, and I'm always going to put the second ordered pair first. So I'm going to do y2, 3, minus the other y value 2, which means I have to also put this x value first. Negative 3 minus the other x value 5. So this is y2 minus y1 over x2 minus x1. And so 3 minus 2 would give us 1. Negative 3 minus 5 would give us a negative 8. So this is a slope of negative 1/8. Part B will be similar, although a little bit more difficult just because you got fraction math involved, and for no other reason. This one is also rise over run, delta y over delta x. So I'm going to do change in the y values, 1/3 minus 1/2, over change in the x values, 1/6 minus a negative 1/3. Several ways you could simplify this. You could take the complex fraction approach from back in section P6 and multiply everything by the least common denominator, or you could just start combining things together. I'm going to do the latter approach. Why not? It honestly doesn't matter. So if I get a common denominator on the top, the common denominator between 2 and 3 would be 6. 1/3 would be 2/6. 1/2 would be 3/6. Common denominator on the bottom is also 1/6, although that changes to a plus in the middle, so be careful. So that would be 1/6 plus 2/6. So on the top we've got 2 minus 3, which would be a negative 1/6, divided by the bottom, which is 1 plus 2, or positive 3/6. There are two ways to think about what happens next. You've got a common factor of 1/6 that you could pull out and reduce, or dividing by a fraction is the same as multiplying by its reciprocal and then reduce. Either way, the 6's are going to cancel, and you're just going to end up with negative 1/3. Let's talk quickly about those special case lines again, a perfectly horizontal line and a perfectly vertical line. And we can do this using the same method. Let's just pick 2 points on the line and do the same thing we did in example 1. So for the horizontal line, let's say I pick this point here, which would be 0, 3, and then I pick the point next to it, 1, 3. Both have a y value of 3. Well, if you try to do rise over run in this case, delta y over delta x, change in y would be 3 minus 3, or 0. The y value is not changing. Change of 0. Change in x exists. 1 minus 0 would give us 1, but 0 divided by anything is 0. So if you have a perfectly horizontal line, because the change in y is always going to be 0, the numerator is always going to be 0, these would always have a slope, which we indicate with the lowercase letter m, of 0. If we try a similar process with the vertical line, we're going to notice something else happening though. Let's say I pick 2 points. Let's do negative 1, 1, and negative 1, 2. If we do rise over run, change in y over change in x, this time the y values are changing. So we're going to do 2 minus 1 over change in x, negative 1 minus negative 1. The x values aren't changing this time around. So the run is 0. That's bad, because remember, we're not allowed to divide by 0. What we would say in this case is that the slope, m, is undefined. It doesn't exist. And this is the only type of line that has an undefined slope. Right, so these are 2 special cases. A perfectly horizontal line will always have a slope of 0. A perfectly vertical line has no slope, period, undefined. So let's bring it all together, because remember, ultimately slope is meant to be a measure of steepness. So I've taken a picture that has a graph of several different lines. These are lines of the form y is equal to mx. We'll talk more about this in just a second, but the number in front of the x is the slope of the line. So for example, this top line here has a slope of 2. This line has a slope of 1. This line has a slope of 1/2. So let's start with y is equal to 0. This is the line on the x-axis in this picture, perfectly horizontal. If you have a positive slope, that means your line is increasing from left to right, because when we do rise over run, if you're reading it from a graph, we always assume that the run is positive. That might not be if you swap the order of your ordered pairs, but if you're just doing it purely from a graphical standpoint, which means the sign is carried by the y values. So if your slope is positive, your y values are getting bigger. The steeper the slope, or rather the steeper the line, the more positive the slope. So 1/2 x is gently increasing from left to right. 1x is a little bit steeper. 2x, a little bit steeper. If you had the line y is equal to 10x, would be a very steep line. If you took it to the extreme and you had something like y is equal to 1000x, that line would almost look like it was perfectly vertical. You will never have a perfectly vertical line though, because those would have undefined slope, and their equation doesn't have a y in it at all. Right? So slope of 0 is kind of the middle, flat. Positive slope means it's tilting upwards. Negative slope, on the other hand, means that the line is decreasing from left to right. So now the lines are tilting downwards. And the idea is the same. The bigger the negative number, the more steep it's going to get in the downward direction. -1/2, kind of gentle. -1, steeper. -2, steeper. Right? The bigger the negative number, the steeper it gets. So slope of 0 is flat. Positive, tilting upwards. Negative, tilting downwards. All right, so now let's talk about the different forms that the equation of a line can take. And I'm going to show you where one of them come from, and only one, and that's because this is the one that most students tend to find hardest to remember. And this is called the point-slope form of a line. So this comes from the formula from the slope that we were talking about earlier. y2 minus y1 over x2 minus x1 is equal to the slope, which we again indicate with the letter lowercase m. Now the thing is that the slope of a line is constant. It never changes. So no matter what 2 points you pick on the line, if you do y2 minus y1 over x2 minus x1, you always get the same result out, the same m, no matter what. And so if I want to create the equation of a line, what I'm going to do is I'm going to take that specific point from example 1, x2, y2, and I'm going to replace it with just the generic point xy. Because no matter what you plug in for x and y, if it's an ordered pair on the line, it would make it the same slope. Right? Ultimately, I want an equation with x and y in it. And so that alters the formula for the slope, though it's the same idea. M is equal to y minus y1 over x minus x1. And then to create what is called the point-slope form of a line, all we need to do is multiply that denominator across to the other side. So I'm going to multiply both sides by x minus x1 to cancel it out. And so point-slope form of a line is y minus y1 is equal to m times x minus x1. Right? If you ever have trouble remembering the point-slope form equation for a line, just remember it comes from the formula for slope. You just multiply the x's across to the other side. Now, point-slope form is only one of many forms that the equation of a line can take, and they're all named after which features most prominently in them. Point-slope form is named as such because in order to build an equation of a line, you need m, the slope, and you need x1, y1, the point. So if you know m, you know x1, y1, you can just plug those in, and that's the equation of a line. Right? Point-slope for point-slope form. Slope-intercept form, which again is probably the most commonly used form for the equation of a line, and you guys are probably pretty familiar with this, is what happens if you multiply all this out and combine like terms. Solve for y, in other words. What you get is y is equal to mx plus b. M, the coefficient of the x, still represents the slope, just like always. And it turns out that this b is the value of the y-intercept. So that's why it's called slope-intercept form, because it's comprised of the slope and the y-intercept. Now, in a couple of problems from now, they're going to be giving us equations of line of all different kinds of form, and they're going to be asking us, based off the equation, what's the slope, what's the y-intercept? Anytime you're asked that, you just solve for y and combine like terms. The coefficient of the x is the slope. The constant is the y-intercept, or at least the y value of the y-intercept. Next up, we've got something called standard form. This will be occasionally your goal for the final answer in a problem. They'll ask you to write the equation of the line in standard form. And the idea is that it's just some constant times x plus some constant times y is equal to a constant without variables. Now there is a key to standard form, and that's that fractions are not allowed. So if you've got something like 1/2 x plus y is equal to 2, that's not standard form. If you want to get it into standard form, you basically get rid of the fractions the same way we solved rational equations. Multiply both sides by the least common denominator. And that will convert the equation into standard form. Ax plus by is equal to c. And then we just have the two special cases. X is equal to some constant represents a vertical line. Y is equal to some constant represents a horizontal line. In example 2, we're going to go beyond just finding the slope of a line connecting 2 points. We're going to find the entire equation of the line. And in this problem, they asked us to solve it for y if possible. In other words, they want it in slope intercept form, y is equal to mx plus b. So there are actually a couple different ways you can go about this process. I choose to build my lines directly into slope-intercept form most of the time. So that's the process I'm going to go through here. And it involves 2 steps. Step 1 is to find m, the slope. And that's going to be exactly the same as example 1. Do rise over run. Change in y over change in x. So for the change in y, if I use the second point, first up in the subtraction would be a -1 minus 6. And then for x's, it would be 4 minus -2. So that would give us a -7 over 4 plus 2, or 6, which is just a -7/6. The second step is to find b, the y-intercept. And the way I go about this is, now that we know what m is, our equation is currently in the state y is equal to -7/6x plus b. So what this means is, if I take either of my points, x, y, it doesn't matter which one you choose, they'll both give you the same result, and I plug it in for x and y, the only unknown in the equation will be b, and we'll be able to solve for it. So in this case, if I plug in -2 for x, so we got -7/6 times -2, I'm going to plug in 6 for y, I get an equation that I can solve for b. So let's see what happens. I'm going to simplify that m times x really quickly. This is a negative times a negative, so it will become a positive, and the 2 will reduce with that denominator of 6. So this is a positive 7/3 plus b. And then, if I want to solve for b, I'm going to subtract 7/3 from both sides to move it across. And now I just need a common denominator. So if I multiply by 3 over 3, 6 is 18/3. And 18 minus 7 would give us 11/3. So I've got m and I've got b. The very last thing you need to do is just bring it all together. Y is equal to m x plus b. All right, so for building it directly into slope-intercept form, find m, use m and a point to find b, put it all together. Part B is similar to example 1, or excuse me, part A. The only difference is that now we're asked to build the equation of a line from a graph. Well, I mean, the idea is, if you can pick out 2 points on the graph, it becomes exactly like example A. We've got 2 ordered pairs, 0, 2, and 3, -1. Now, this will be a little bit different. I'm going to talk to you a little bit more about a shortcut we can take in a few seconds. But the first step is still the same. Find the slope. So m, our rise over run, I'm going to do y2 minus y1 over x2 minus x1. So we get a slope of -3 over 3, or a slope of -1, which means every time we go 1 unit to the right, the y value goes 1 down. All right, so far for y is equal to mx plus b, we got y is equal to -1 times x plus b, or just -x plus b. Now, if you want to find b, you can plug in either of these points, or you can take a shortcut. Because we can clearly see the y-intercept on this graph, you can actually just read b directly off of the ordered pair. It's going to be 2 in this case. To show you that it works that way, imagine plugging in the point 0, 2 for xy. The y value goes over here on the left. The x value is always going to be 0 if you plug in the y-intercept. So you just get b is equal to 2. Right? Essentially, if you take y is equal to mx plus b, and you plug in 0 for x, you just get y is equal to b, the y-intercept. All right, and then last but not least, we just need to bring it all together. Y is equal to -x mx plus b. In example 3, we're asked to write the equation of the line passing through these 2 points. The only difference between example 3 and example 2 is that this time we're asked to write our final answer in standard form. ax plus by is equal to c. Truth be told, the problem starts off almost exactly the same. You can even build your line in slope-intercept form first. It just adds some extra steps on to the end of the problem, getting it into the appropriate format. So let's start by just building the equation of a line. So if I look for m first, the slope, change in y over change in x, y2 minus y1 over x2 minus x1. Well, we got some fraction math here, so I'm going to get some common denominators. So on the top, I'm going to get a common denominator of 3. So that's a -6/3 minus 2/3. And on the bottom, I'm going to get a common denominator of 2. We got a -1/2 minus 4/2. So this would be a -8/3 divided by a -5/2. Well, first off, a negative divided by a negative is a positive, so we don't have to worry about that. And then dividing by a fraction is the same as multiplying by the reciprocal. And based off what I see here, nothing in the denominator will reduce with anything in the numerator. So the best we can do is just multiply these together and get 8 times 2 or 16 over 3 times 5 or 15. And so this is our slope. All right, so next up, we need to find the y-intercept b. So far we've got y is equal to m x plus b. And I'm going to plug one of these 2 points we started with in for x and y. Now, truth be told, it doesn't matter which one you plug in for x and y, but because we've got fractions in the mix here, and because x is being multiplied by something while y isn't, if you have a choice, it's better to keep x simple and let y be the more complicated option. So I'm actually going to choose this point 2 2/3, just because x is really nice and easy with that one. And so if I plug in 2/3 for y, 2/3 is equal to 16/15, and now I plug in 2 for x plus b. You multiply a fraction by 2, just doubles the numerator, so we get 32/15 plus b. I'm going to subtract 32/15 to move it across to the other side. And now I need to get a common denominator by multiplying by 5/5. And so b is going to be 10/15 minus 32/15, or a negative 22/15. So if we were writing our equation in slope-intercept form, y is equal to mx plus b, we would have y is equal to 16/15 x plus b, which is a negative number, so it would be minus 22/15. That's not what we want though. We want standard form, so it's just going to require 1 or 2 extra steps here. And the other thing to remember about standard form is no fractions. So the first thing I'm going to do is get rid of these denominators of 15. The common denominator is clearly 15 itself. So I'm going to multiply both sides by 15. So we get 15y on the left, and on the right, this 15 just cancels out both of the denominators. So we get 16x minus 22. And the very last thing I need to do in order to get this into standard form is to get x and y on the same side. So you've got options here. You could either subtract the 16x over to the left-hand side, or you could subtract the 15y and add the 22y to rearrange. And that would give you 16x minus 15y is equal to a positive 22. Note these two forms are the same. The only difference is that you would multiply both sides of one by negative 1 to get the other. So they are equivalent to each other. Now, although either one of these is technically correct, the version that is usually considered the best or the simplest form is the one with a positive coefficient for x. And so we would go with 16x minus 15y is equal to 22. And if all of these had a common factor and you could reduce, then you should do that as well. All right, so in example 4, they're going to ask us to find the slope and the y-intercept of a couple of lines. And so anytime you're asked for slope or y-intercept, that means you should be looking for the form y is equal to mx plus b, because then you can just pick out the slope and the y-intercept directly. The one thing you need to be careful about is with vertical lines and even horizontal lines to some degree, because those lines are special cases which might not fit necessarily with what we're used to, and so instead you need to just think about what the graph is, what the corresponding slope would be from what we talked about earlier, and if it even has a y-intercept at all. All right, so let's start with part A. Now this currently is a line that has been put together in slope point form, that y minus y1 is equal to m times x minus x1. This is another option for building the equation of a line. If you did this instead of the method I was doing earlier, you would still calculate slope first, same as before, and you would plug that in, and then you would just plug one of your points x1, y1 in directly. So you wouldn't solve for b in a separate step. Now the trade-off for that is it's still the same amount of work, because in order to get it into the form y is equal to mx plus b, you would have to distribute and combine like terms. All right, so whether you build your lines in point slope form or solve for b in a separate step and build it in slope intercept form, it doesn't matter. It's user's choice. So in this case, if I want to get y is equal to mx plus b so we can pick out the intercept, we need to distribute and combine like terms. So if we multiply the negative 3/2 through, we would get a negative 3/2 times x plus a negative 3/2 times 5 which would just multiply into the numerator, right? If you think of it like multiplying fractions. So that would be a negative 15 halves. But we still got this minus 2 that we need to get rid of. So if I add 2 to both sides, to move it across to the right, the last thing I need to do to get y is equal to mx plus b is combine the constant terms. So if I get a common denominator, I'm going to do a little bit of scratch work here. We've got negative 15 halves plus 4 halves, and a negative 15 plus 4 would be a negative 11. So this equation would be y is equal to negative 3 halves x minus 11 halves. So now we can just pick it out. M, the slope, which you could have picked out right from the very beginning, even in this form, is negative 3 halves. B, which is the reason why we went through the trouble of multiplying everything out and combining like terms, is negative 11 halves, but remember that's just the y value of the ordered pair. For a y-intercept, x is always 0. So as an ordered pair, it would be 0, negative 11 halves. Right? In general, the y-intercept of a line is 0, b. Right, so that's part A. Part B is next. We've got minus y plus 5 is equal to 0. So if I subtract 5 from both sides, and then multiply or divide by negative 1, this is the equation y is equal to 5. This is a special case. This is a horizontal line, so instead just think about what's going on. You've got a horizontal line at a y value of 5. You should know what the slope of a horizontal line is equal to. M is equal to 0 in this case. And the y-intercept would be 0, 5. Now, horizontal lines you can actually still think of as y is equal to mx plus b. Those still work. Vertical lines wouldn't because there's no y at all. But if you take y is equal to 5, you can actually think of this as y is equal to 0x plus 5. And so you can see that this is a line with slope 0 and a y value of the y-intercept of positive 5, which is exactly what we see over here. For the remainder of the section, we're going to be talking about two special relationships between lines, and those are parallel and perpendicular lines. So by definition, parallel lines are lines that never cross each other. They never intersect at all. And so that means if these lines are supposed to be traveling in the same direction and never touching, infinitely far, that means they have to have the exact same steepness. In other words, they have to have matching slopes. So in this picture, I graphed the line 2x plus 3 and 2x minus 1. These are two lines with slope 2, right? M is 2 in both of these cases. And so because they have the exact same slope, these lines are parallel with each other. Perpendicular lines are lines that intersect at a right angle, a 90-degree angle. In order for two lines to be perpendicular to each other, well, obviously if one is increasing from left to right, the other has to be decreasing, so the signs have to be different, but that's not good enough. Because, for example, if you had a line of positive 2x, it would be pretty steep positive, and negative 2x, that would be pretty steep negative. So you don't get a right angle in between. So it's not just enough to change the signs, their slopes are opposite reciprocals. So you have to flip the sign and take the reciprocal. So this graph here is of the lines 2x plus 3 and negative 1/2 x minus 1. So one has a slope of positive 2, or 2 over 1, and the other has a slope of negative 1/2. So change the sign, take the reciprocal. Now it's important to note that there are infinitely many perpendicular lines with 2x plus 3. All you would have to do is adjust the y-intercept. If I had set that to negative 1/2 x plus 0, it would have just shifted this line up a little bit, but it still would have intercepted at a right angle, right? Any line that has opposite reciprocal slope will be perpendicular. All right, so to kind of summarize the previous two slides, parallel lines, exact same slope, perpendicular lines, opposite reciprocal slope. So below, I've given us the slope of two lines. One is 2/3, one is -5. Take a minute, pause the video, see if you can find the corresponding slopes of a parallel and a perpendicular line to each of the two. All right, so let's start with the line that has slope 2/3. A parallel line would have to have the exact same slope, so it would also be 2/3. A perpendicular line would have to have a slope of the opposite reciprocal, so it would have a slope of -3/2. For the line with slope -5, a parallel line would also have to have a slope of -5. A perpendicular line, and again, you can always think of a number as being over 1 if it's a little bit tricky at first. The opposite reciprocal slope would be positive this time, 1/5. All right, so for the rest of the problems in this section, it's just combining together the concepts of parallel and perpendicular slopes with the previous examples we worked, finding the equation of a line or finding the slope and the y-intercept of a line, things of that nature. So for example 5, all we're asked to do is to find the slope. So we're not building the equation of a line yet, just find the slope. And in part A, we're going to start with a line parallel to 3x minus 9y is equal to 4. Right, so these are both lines in standard form. Otherwise, this problem would probably be a little bit too easy. The trick is to take each form, each line, write it into the form mx plus b so that you can pick out the slope, and then do the same thing we did on the previous slide. Figure out what the parallel or perpendicular slope would have to be. So for part A, if we've got 3x minus 9y is equal to 4, I want to solve that for y. So let's start by subtracting the 3x across to the other side. So the minus 9y stays on the left, the plus 4 stays on the right, just shifting terms around. And then to get y by itself, I'm going to divide both sides by -9. Right? Now in order to get truly mx plus b, I'm going to use that property of exponents, or excuse me, properties of fraction addition, which says if you want to add two fractions together with a common denominator, you just add their numerators, but I'm going to go in reverse. I'm going to split it up. So this would be a -3x over 9, or excuse me, a -3x over -9, plus a 4 over -9. And so the -3 over -9 would reduce to a positive 1/3. And this is just a -4/9. But honestly, this doesn't matter to us at all right now. All we cared about was the slope. So if the slope of this line is 1/3, what about the line parallel? Well, since parallel lines have the same slope, it would also have to have a slope of 1/3. All right, so try doing the same thing for part B. See what slope a line perpendicular to 2x minus 3y is equal to 8 would have. Try pausing the video here. Same idea, solve for y. So if I subtract the x over to the other side, you could also move the y over if you want to deal with fewer negative numbers. But that means you would also have to move the 8. Divide the negative 3, break it up. So we got a negative 2x over negative 3 and an 8 over negative 3, which would be a positive 2/3 x minus 8/3. So if the slope of this line is 2/3, the perpendicular line would have to be the opposite reciprocal, negative 3/2. All right, so example 6 takes it one step further. Not only are we finding the slope of the parallel or perpendicular line, they're also now giving us a point that it needs to contain. And if you've got slope and a point, you can build the entire equation. All right, so be a little bit careful here. This point is not related to this equation. Right? There's a lot of information here. Make sure you keep it separate. This line equation here is solely to find our slope m, just like in example 5. Once we do that, we will use the slope parallel or perpendicular plus this point to create the equation of the parallel or perpendicular line. All right, so keep it separate. All right, so to begin with, we need to find the slope. So I'm going to start by solving this equation for y. Get 9y is equal to negative 4x plus 5. Divide by 9. And I'm going to go ahead and break it up in one step this time. The more of these problems you work, the faster you'll get at them, of course, like all problems in math. So we've got negative 4/9 x plus 5/9, which means slope of this line, and therefore our parallel slope as well, needs to be negative 4/9. Now that we've got slope and we've got a point, we can build our equation. Y is equal to mx plus b. Y is 2. X is negative 4. All right, multiply these two together. That turns into a positive 16/9. So I subtract negative 16/9 across to the other side. Or excuse me, I subtract positive 16/9, which makes it become negative 16/9. And then I get a common denominator. So 2 would be 18 over 9. 18 over 9 minus 16 over 9 would be 2/9. So B is 2/9. All right, just a little bit of fraction math. So now we put it all together. Y is equal to mx plus b. M was negative 4/9. B was a positive 2/9. Now I put a box around that, but I shouldn't have been quite so hasty. Why might that be? Well, if we read the problem carefully here, I didn't underline it this time, but we were asked to write the equation in standard form. So we're not quite done yet. Last but not least, we need to get it in that form. Ax plus by is equal to c. And so what I'm going to do to get rid of these denominators of 9 is multiply both sides of the equation by 9. So we get 9y, and then it just cancels the denominators on the right. So it's equal to negative 4x plus 2. And then I just need to add 4x to both sides to move it over to the left. And so our final answer for real this time would be 4x plus 9y is equal to 2. All right, so let's take a look at one more similar to part A. This time the only difference is that we're dealing with the perpendicular line. So try pausing the video here and see if you can find the solution to example 6, part B. All right, so again, we're going to use this line purely to find the slope. So if I solve this for y, if I subtract the x over to the right, divide by -2. All right, so for the x, we would have -1 over -2, or a positive 1/2 x. And then this would be a positive 3 over -2. So -3/2. So the slope of this line is 1/2. But if we want a perpendicular line, its slope, m, needs to be the opposite reciprocal, 2 over 1, which is just 2. All right, now that we've got m, we've got our point, we can put the line together. Y is equal to mx plus b. All right, so if I plug in 1 for y, be careful not to get these backwards. Remember, the second one is the y value, the first one is the x value, is equal to m times x plus b. So if I subtract 6 from both sides, b would be equal to -5. And so y is equal to mx plus b, -2x minus 5. This one's pretty easy to get in standard form. Because there are no fractions, all we need to do is add 2x to both sides. 5 on the right, still minus. And we're good to go. All right, and last but not least, in example C, we've got one of those special lines. Because if you're dealing with this idea of parallel and perpendicular lines for horizontal and vertical lines, the idea of opposite reciprocal slope doesn't work. Because the slope of one is undefined and the slope of the other is 0. You could think of those as reciprocals, but it's a little bit hazy. So instead, what you want to do is you just want to graph the line and think about it. Right? These are pretty straightforward once you get into it. So the line that we want to find something perpendicular to is x is equal to 4. X is equal to 4 would be a vertical line going through the x value of 4. So if we want something perpendicular to a vertical line, we need a perfectly horizontal line, right? Horizontal lines and vertical lines are perpendicular to each other. Right? So which means my equation needs to be y is equal to something to draw that equation of a horizontal line. Well, we know it needs to contain the point 2, 5. They're basically giving you the y value that you need to set it equal to. If you need to go through a point with a y value of 5, that means your line needs to be y is equal to 5. All right, so these problems are actually the fastest if you get used to the concept. Just keep in mind that you do have to treat vertical and horizontal lines a little bit differently when dealing with this idea of parallel and perpendicular lines. And that is it for section 1.4. So there's a lot of information with lines here, and it trips a lot of students up, especially once you get to the parallel and perpendicular, and they start adding a lot of information at once in a single problem. So let's try to break it down. Types of problems in this section is given 2 points, you should be able to do rise over run in order to figure out what the slope is. The second type of problem is taking it one step further than that. You should be able to build the entire equation of a line once you find the slope and you know a point. And you should be able to write that final answer in either slope-intercept form, solve for y, or standard form, ax plus by is equal to c. The third type of problem is pretty easy once you get used to the algebra behind it. Determine the slope and y-intercept of a line in any form. That's where you just solve for y. Slope is m. Y-intercept has an x value of 0 and a y value of b. And then last but not least is just combining these problems together with the idea of parallel lines and perpendicular lines, right? So it's not quite as much as it seems once you get it all down, because problem 2 is just an extension of problem 1, and problem type 4 is just one more extension of the previous. So this is really a section that just starts with the basics and then just starts building more on top of it. All right, so with all that said, if you guys have any questions about anything, make sure you let me know, and I will see you in the next video.